In this video, we're going to go over the remaining basic integration rules that you guys have to know. We're going to start with natural log. So if you remember, the derivative of the natural log of u, where u is a function of x, this is 1 over u du. So it only makes sense that the integral of 1 over u du is ln of u, like this. And so we're going to use this to our advantage to find the integrals of all 6 basic trig functions. You already know that the integral of sine is negative cosine and the integral of cosine is sine. But what about tangent? So most people would probably say that this is secant squared x, right? Because of the derivative relationships. But this is not true because I'll show you. So tangent can be written as sine x over cosine x dx. And then using our u substitution, we can say we'll let u equal cosine of x. And then du dx equals negative sine of x. And then solving for du, we get du is negative sine x dx, like this. And notice we have positive sine x dx up top, so we can multiply by negative inside and outside. So the negative on the outside stays, and then we use the negative in to make du. So this is 1 over u du. And we should look at that. This is the integral for ln. So when we solve this, we have this is negative ln of u plus c. And since we said u is cosine x, this is negative ln of cosine x plus c. Notice that this is definitely not secant squared x. And the integral for cotangent of x can be solved in a similar manner, like this. So you see I've separated cotangent into cosine x over sine x, and I've let u equal sine x so we can make the 1 over u du substitution, and from which we can easily see that the integral of cotangent is ln of sine x, not negative cosecant squared x. For secant x and cosecant x, the way we solve them is a little different. We're still going to use the 1 over u du, but it's a little more complicated how we get there. So we can say this is integral of secant x over 1 dx. And then we can multiply the numerator and denominator by secant x plus tangent x on the top and bottom. See how these, I haven't changed the integral because these will cancel to 1 if I don't do anything. So it'll still be integral of secant x dx. So when we distribute this, we get the integral of secant squared x plus secant x tangent x over secant x plus tangent x, like this. And so now if we let u equal secant x plus tangent x, taking the derivative of both sides with respect to x gives us du dx equals secant x tangent x plus secant squared x. And when we solve for du, we get secant x tangent x plus secant squared x dx. And now if you notice, this is exactly what we have on top here. So when we make this substitution, this turns into integral of 1 over u du. And we know this is ln of u plus c. And since u is secant x plus tangent x, the answer to this integral is ln of secant x plus tangent x plus c, like this. And the way we solve the integral of cosecant x dx is very similar to secant x dx, only this time when we make a substitution, we have this negative out here, so we have to multiply on the outside and the inside, so we can use a negative to get du. And so that's why the answer is negative ln of cosecant x plus cotangent x plus c. And here are the integrals of the 6 basic trig functions. We're going to end the chapter by going over integrals that result in inverse trig functions. And you'll notice that here there's only 3, but for derivatives, we memorize 6. Well, remember I also said in the derivatives chapter that half of the derivative rules are just negatives of another. So we only have to memorize 3 for integration, because if we have negative, we can just factor it out and then proceed like usual. The first formula is the one that results in arcsine, and this is the integral of du over square root of a squared minus u squared, where a is any constant. Then this is arcsine of u over a plus c. The second formula is for arctangent. So this is integral of du over a squared plus u squared. This is 1 over a arctan of u over a plus c. And the third formula is for arcsecant. So if we have the integral of du over u times the square root of u squared minus a squared, then this is equal to 1 over a arcsecant of absolute value of u over a plus c. And as always, I'll end the video with some examples. For this first example, we're asked to find the integral of 2x plus e to the x all over x squared plus e to the x dx. So right away, there's nothing we can do without making a substitution. So I'm going to say we're going to let u equal the denominator x squared plus e to the x. And when we take the derivative with respect to x on both sides, we get this is 2x plus e to the x. And when we solve for du, we get du equals 2x plus e to the x dx. And wouldn't you know, we have this on the top. So this is integral of 1 over u du, which is ln of u plus c, which is ln of x squared plus e to the x plus c. Whenever you have rational functions like this, it's a good practice to test if you can set the denominator equal to u and see if your du simplifies to your numerator, because then that makes the problem a lot simpler. And for our second example, we're going to find the integral of 6x over 7 plus x to the fourth dx. So right away, we have a rational function. So let's see if we can make the denominator u and if the du simplifies to our numerator. So we have this equal to u. Then if we take du dx, we have this is 4x cubed, and du equals 4x cubed dx. Notice we don't have enough x up top to make this work, so we have to try another way. If you'll notice, this looks kind of similar to the arctan integral. So I'm going to let a squared equals 7 and u squared equal x to the fourth. And then solving for a, we have square root of 7, and solving for u, we have this is x squared. And when we find du dx, we get this is 2x, so du is 2x dx. And now here, we need 2x dx, but we have 6x dx. So what we can do is factor out a 3 to the outside of the integral. So we have 3 times the integral of 2x over 7 plus x to the fourth dx. And now we can use all this information to make the substitution. This is 3 times the integral of du over a squared plus u squared, which is arctangent. So we have 3 times, so 1 over a is 1 over square root of 7 arctangent of, here u is x squared, so x squared over the square root of 7 plus c, which simplifies to 3 over root 7 arctan x squared over root 7 plus c. And then if you really wanted to, you could rationalize the denominators here to get, and this is the answer to this problem.